Here we go. Hello, everyone. Welcome back to some STEM Effect STEM streams, Swift Playground Edition. Sorry, my chair's being a little weird. um, we are on our 8th episode of Swift Playgrounds. Last episode, we finished up conditional code. We did a little decision tree. And if you remember, we're starting to get pretty tricky here. We're getting pretty complicated. So we're learning a lot and we're learning fast. So if I just run this last exercise that we did, basically we looped through it 5 times and we ran little conditions. And if you were on a toggle that wasn't toggled, it toggled it. And if you were on a gem, it collected it. And it just kind of went around and around. So it's pretty crazy how we can do all that now, especially considering we just started, a month ago or whatever, maybe 2 months ago, how much we've learned. So our next lesson is going to be on logical operators. So let's get into that. Could you be more specific? Boom, logical operators. So earlier you used an if statement to plan for different situations, but what if you could make your conditional code even more powerful? If light is green, move forward, else wait. In code, an operator is a symbol which represents an action. So you have an equal, a plus, and an and. A logical operator is a type of operator that you can use to make your conditional code more specific. Each of these three operators, nots, um, maybe we use some greater than and equal to, stuff like that. So the ones I go over right now are and, which is the double ampersand. That's what those two icons are called. The or, which is the 2 bars, which you can do by um, shift and then the slash right below the backspace. I don't know if that's a forward slash or a backslash. I'm assuming it's a back, maybe. I don't know, but it's up at the right side there. And then a not, which is just an exclamation point. The logical and operator is so this code runs only if conditions are true. So if blocked and on a gem, collect the gem and turn around. So has to be both things are true in an if condition. So both is blocked and is on gem must be true for the code to run. So like I said, both conditions have to be true. The or operator is similar, but it doesn't have to be true. So the code runs if at least one of the conditions is true. So if you're on a gem or you're on a switch, do a dance. So this is how we would write it with those 2 bars. So either is on gem or is on switch must be true for byte to do the dance. Byte also dances if both conditions are true. So if he's on a gem and he's on a switch and is on a switch, then he can do a dance as well. So it can both be true, but one of them has to be true no matter what. And then the not operator, just working down the line here, is basically all if it's the opposite or not. So this operator changes a condition to its opposite. For example, if on gem is true, then not on gem is false. So if not blocked, fly away. So if the not operator changes the condition, is blocked from false to true. So if it is not, if so this is originally it was saying if is blocked, fly away. Now with the not operator in front of the is blocked, you read it as if is not blocked, fly away. Or you can read it straight left to right and say if not is blocked, which for some people might be easier because you're reading it, but for other people it might be harder to understand if you do that in your head. But anyways, so let's get to it. Use the not operator to adjust your character's pathway. There's no gem on a tile. Okay, hopefully this loads. It's giving me a blue screen. There we go. Got the little soundtrack going too. So the logical not operator changes the value of a boolean to its opposite. It inverts the value, so it switches it around from 0 to 1 or whatever, 1 to 0. Excuse me. I should use my elbow, I'm sorry. Bad etiquette. So for example, if the condition is blocked is false, then not is blocked is true. Sometimes it can be kind of confusing. Just got to think about it a little bit. So, and running these puzzles will help kind of help you visualize this stuff. So run the puzzle a few times to see what changes. Notice that there are always 4 gems, but one is on the bottom, at the bottom of the stairway. When there's no gem in the top platform, the stairs extend from that tile. Use not to determine when your character is not on a gem. If not on a gem, turn and collect the gem at the end of the stairs. Otherwise, collect the gem. Okay, so let's just run this to start. Like I said, we're starting to get into some more complicated stuff, so let's just move through this a little more slowly. This might be a 3-part thing. We've had usually doing 2 parts, this might be 3-part. We'll see. So let's just run this in general. So Byte's just going to go through and basically say, and you're just going to move forward in our for loop 4 times. So 1, 2, 3, 4. So now what we need to do is there will randomly be, as you can see when we ran it, I'll run it again. There will be a random staircase, and that'll go down to the gem at the end of the stairs. Otherwise, it'll always be in front of them. So we need to write an if statement, and let's just make a function called, we'll call it, whoops, I should probably write function name, collect dat gem. And then basically we're going to say so we're going to start, we're going to move forward, and then we're basically going to say if whoops, let's do this. If is on gem. So if he's on a gem, then we're gonna collect the gem. Okay. Else so basically saying if is on gem, collect the gem. Else, what are we gonna do? Collect the other gem, right? So we can do use, oh wait, hold on. What is the goal for this? Use exclamation point to determine when your character is not on a gem. Okay, so we're gonna switch this around. So if is not on a gem, then we're going to turn right, turn left, sorry. Move forward. So we'll be on the stairs, move forward again. And then we'll be under the gem at the bottom of the stairs. We're going to collect that gem. And then we're going to turn around. So we're going to we'll turn right now. And then turn right again. And then move forward back up the stairs. And then move forward again to the top platform. And then turn left. And that's it. Excuse me. Else, we're going to simply collect the gem. Whoops. Okay, so does that make sense? So we made a function basically saying if byte is not, with exclamation point, not on the gem, then we're going to go, that means he needs to go and collect the gem down the stairs and come back. But if he is on the gem, then we're just going to collect the gem. So let's move this. And see. Hopefully I didn't ruin that. Enter. Enter. There we go. So we have our function of collect that gem. So we're going to move forward. And we're going to run collect that gem. I think that's right? So he's going to start at the arrow, move forward once, run the collect the gem, and he's going to move forward again. Yeah, so that should be good. So let's run this step through. So let's just see. So it's going to generate a random thing. Okay. He is on a gem, so it's going to go to that else and collect the gem. And then it's going to move forward again. It's going to say, are you on the gem? If you're not, oh, you are. Collect the gem. And we're going to go again. Oh, he's on the gem again. Collect it. Bam. And then this one, watch, it's going to say, oh, you're not on the gem. Let's collect this gem on the bottom of the stairs. There we go. And that's how we do it, folks. Oh, my soundboard's not working. I'm not triggered. I'm not triggered. So that was pretty cool. So that's our first kind of dive into the not operator. Some people call it a bang operator. But it's basically, so like we've kind of gone over. Oops, there we go. Right there. So this is on gem. If you put the exclamation point in front, that's not. So it switches it around. So it's saying if you are not on the gem instead of if you are on the gem. Alright, what's it say? So it says your main or is on close switch. What you're saying is if not on a gem, do this. Correct. Now we could have figured that last problem out without using that, but I think the goal, like I said, I kind of got a little stuck, but the goal was to use that, so we made him happy. Okay, so what is this? This looks interesting. Spiral of not. Use the not operator to turn left when blocked. Okay. Just like the previous exercise, the puzzle world in this challenge is slightly different each time you run it. Try figuring out how to use the logical not operator to solve it. Oh, we got a new condition we can use. The condition is blocked is either true or false, giving a Boolean value. If you can't move forward, one tile in the current direction is blocked as true. If you can move forward, is blocked as false. So we can use is blocked, so basically say not true, or we're basically saying if it is blocked or if it is not blocked with the bang or with the exclamation point, and it'll be either true or false. If it's true, then we'll go. If it's false, then it's not. So I'm assuming, I'm really curious to see what we're doing. So let's just, we're gonna have to get to the toggle, and we're gonna toggle the switch. So, and we're running this for loop 13 times. Is that how many squares there are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, so there's 13 squares. Okay. So, let's see. Let's write a function in here again. Because I don't want to write all of this in a for loop. I think that's... No, we're not going to do that. We're better than that. So let's do... Byte. Move. Forward. 4 words. Let's do forwards. Okay, so we're gonna have to use the not conditional. So we're gonna do an if statement. If blocked, but we're gonna use the not conditional. If is blocked. So basically this is the not, right here. So right there, boom. So So you're going to basically saying if it is not blocked, then we're going to move forward. Move forward. Boom. Else see, I don't really know what we're supposed to do if you are blocked. Do you just turn left? Use the not operator to turn left when blocked. So if you are blocked, we'll just turn left and see what happens. Else turn left. Oh, I see. So you'll be blocked. Yeah. I'm assuming the spiral will change, but you always have to turn left. And then we'll make another function here. Actually, yeah, no, we'll make another function. Basically saying bite on toggle. And we're going to say if we're going to use the not operator again. So we're going to say if byte is not on an open switch, then we're going to toggle that switch. Toggle switch. And that's it. If he's on a, yeah, that's it. So then let's space this out a little more. So we're just gonna run byte move forwards, and then after every one of those, we're gonna say, are you on a toggle, essentially. So byte on toggle. Whoops, I always do that. Okay. So we're gonna check, I'm assuming the toggle is always gonna be at the end, but we'll just run it every time. Maybe they'll move the toggle around. If not, we can move this byte on toggle after the for loop, after he moves 13 times. But we'll see. Let's run it first. Alright, let's see what happens. Oh, so the spiral moves. So we're not blocked, so we're going to move forward. Yeah, the byte on toggle. We didn't calculate that right. We're gonna stop this. Stop it. Stop it. Sorry, byte. So I'm pretty sure we know that. What? Oh man, it closed on me. It just crashed. Oh, at least it saved all my stuff. So we don't even need this byte on toggle function. We don't need it. We don't need it. So we're just gonna run byte moves forwards, and then after that we're gonna run toggle switch right at the end. So we're not toggling every single time. That makes no sense. All right, so this is actually shorter than I thought, but let's do it. Let's step through again. See what the little spiral does. All right. So if you're not blocked, move forward. Run through this. He's just gonna move forward all the way up until he's gonna move forward 4 more times, I think. Oh, that's a baby crying. That's not what we want. It's also not what we want. Is it this one? Why is my soundboard not working? It's this one. Oh, I like that one. I could use that a lot. There we go. Where's the applause? Oh, there's 3. Okay, so everyone's cheering by on. So we got him going down the right path. So basically, he's going down every time he can't move forward, he's turning left, essentially. And now that I think about it, we probably could have ran this in the for loop. It's really only, 1, 2, 3, 4, 5 lines of code. But we need to work around, we need to work on making functions anyways. Uh-oh, what? Okay. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why did he only go 12? Oh, turn left counts as a thing. So we had to turn left twice. Dang, that's interesting. Okay. So there's two ways we can solve this. This will probably be the last thing because it would take too long. But we're going slow, we're learning this. Anyways. So we always know that he'll have to turn 3 times. So we can just update this number to say instead of 13, 16. Or we can do some like dynamic thing, basically moving this until he toggles, until he lands on a switch. But I think I'm going to save that for a later day. So let's see. Let's just run. Unless it turns, yeah, no. Boom. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Boom. So we got it. I wonder what the best way to do that was. I'm sure updating the for loop probably. Oh, you know what we could have done? We could have done turn left and move forward. We could have added another move forward after you turn left. So he's always moving forward at least one every time. But I mean, like I've said multiple times, there's multiple ways to solve programming problems, coding issues. There's no right or wrong way. I'm sure we could have added turn left, move forward, and that's probably what they were envisioning, leaving this at 13. But I mean, let's just run it again. Boom. Solved it again. So that works too. So in this case, we knew that there's always 13 squares, and there's always going to be 3 turns. So multiple ways you can solve that. Anywho, let's see here. What did they say? Excellent. Using the logical non-operator in the condition is blocked. You'll always know when your character is not blocked and can move forward. This is an extremely handy trick to use in other places in your code. So I think that's the last one for today, guys. We basically just focused on the not operator, and the next episode looks like we're going to get into the and operator. So, oh, and we only have 3 more left, so this is a more complicated section, but it looks like it's also a little shorter, probably because there's just a lot that goes into it. It's simple, but it's tricky to think about. It's harder to think about in your mind, but it's nice to visualize all this stuff. So next time we'll get into and or, which we went over in the introduction, but we'll go over those again. And then it looks like we'll get a cool little challenge at the end. So thanks for tuning in. Shout out to Levi if he's watching. And I will talk to y'all later. Happy coding. Love you.